Hi, my name is Joel. Welcome to my physics class. Today we are going to try and understand the famous formula E equals mc squared. What does it really mean when we say is equal to mc squared? You will agree with me that this is arguably the most popular equation in physics, which was derived by Albert Einstein in 1905. So first of all, let us label it. What is E? E is energy, and in this case, energy, rest energy. This is mass. This is what? Speed of light, which is what? 3 times 10 raised by 8 meter per second squared. Right. So how did Albert Einstein come up with this equation? And what does it mean is what we're trying to understand in this video. So how did Albert Einstein come about this? Now, if you know the theory of relativity, Albert Einstein is trying to explain that in relativity, what is actually happening is, for example, we have an event happening here. Something is happening, let's say a birthday party is happening, and we have an observer on a tour here, say a security personnel observing this event. And then we have another observer here who is moving in a vehicle, observing the event too. What Albert Einstein is saying, the record of this event by this observer in a moving frame is going to be different from this observer on a stationary frame. The record of their observation of this event is going to be different. So this event, whatever they're recording, is relative to whether this is a stationary observer or this is a moving observer. So that is what relativity is. The record of their event is relative to whether they are moving or they are stationary, and even their position. Right. So Albert Einstein thought about this and he said, okay, for any particle in space, you're going to observe, okay, let's say for any particle in space of magnitude 10, let us assume that this particle releases, this is the wave field of this particle, and it releases 2 photons in opposite directions. Why 2 photons? Because we are trying to make sure that this particle in space is stationary, it doesn't move, because if it shoots only one particle, there's going to be a recoil, right? So Albert Einstein says, let us assume that it shoots 2 particles in opposite directions so that it can keep it put, right? And the magnitude of this particle is 10. This photon is 1, this is 1. So at the end of the day, after shooting this particle, is going to be left with what? 8 in magnitude. This is simple. Albert Einstein is here observing what is happening to this. And he says that assuming his friend is in space also, but she is in a jet observing the same thing. This is his friend in a jet observing the same thing. She is moving in this direction. She is going to observe that this particle is moving in the opposite direction, even though in real, the particle is stationary. Because she is moving in this direction, she is going to observe that this particle is moving in this direction. And the wave, since the particle is moving, the wave of its movement is going to be like this. It's going to be compressed on one side. So it's going to be compressed on this side since it's moving on this direction, and it's going to expand on this side. So Albert Einstein says that this compressed part is going to be a magnitude of 2 because it is already the frequency at which the amplitude is moving is already twice this. So what will happen on this side of the photon? Since it has expanded, it is going to be very small. So let's say 0.2. So at the end of the day, you observe that the magnitude has lost a mass compared to this is 8. This will be what? When you subtract 10 minus 2.0, you're going to have what? 7.8. So the difference here of the magnitude of the particle in space is 7.8, while here is 8. So why are we observing this? We go back to relativity. We said that his friend is moving, so she will see this particle as moving in the opposite direction while he is stationary. So what he observed is different from what she is going to observe. So at the end of the day, he asks, what is the change in mass between this and this? What he's trying to say in general is that if you lose energy, you are definitely going to lose mass. If you lose energy, you are definitely going to lose mass. But based on the two observers moving and stationary, there is a change in mass also. So at the end of his calculation, he observed that after putting some things into consideration, and the things that he put into consideration is time dilation, he puts Doppler effect also into consideration. Doppler effect. So these things influenced his calculation. If you want to know the meaning of those two things, please drop a comment in the comment section so that we can talk about these two properties in full. Right? So these are the two things he put into consideration. And at the end of the day, he found out that the change in mass is equal to the energy of the particle at rest all over speed of light raised power 2. Is equal to what? Energy of the particle at rest divided by the speed of light after calculating. So if you observe this, it means that energy of a rest mass is equal to what? mc squared. So this is how Albert Einstein came up with the equation E equal to mc squared. So now the question, how did he come about it? I mean, what does E equals mc squared means? What does E equals mc squared means? Right. E equals mc squared means that for any material matter in space, the energy of that material matter or particle is equal to the mass of that particle multiplied by the speed of light. What does it really mean in real life? It means that if you want to calculate the energy of a mass, say for example, now you want to calculate my potential energy, because remember we said this is energy, the potential that I possess as per energy. You're going to calculate my mass is 69 kg, right? Multiply by the speed of light. This is the potential energy that I possess as a mass. It means that if I can harness all of this energy, I'm going to have an energy of this magnitude. And I think about it, I say, okay, this is why in Hollywood it is possible to create superheroes. It means that they just have the ability to harness more of the energies that we have. I mean, that they have in their body. So we have people that can disappear. We have people that can run almost as fast as the speed of light, like flash. So this is exactly what Albert Einstein is trying to say. That if you want to calculate the energy of a rest mass, the potential energy, you multiply the mass of that energy times the speed of light. So I hope this is clear and we understand it. If there is any confusion, you can leave your question in the comment section and we will try to answer you. Thank you.